say if you have a container with 1 liter volume, and this is something that we call a manometer. And the manometer there is that you have a valve here, you can close it, and then here you have a U-shaped tube. We used to call it U-tube, but not anymore. U-tube has different meaning this generation. So we have some mercury in there. Okay, so you can put some air or a nitrogen gas in here at certain temperature. Now that gas will generate a pressure. So the pressure for the nitrogen gas there would be somewhere around 186 millimeters of mercury, for example. Okay. Now if you have the same container and different amount of oxygen gas, put it in there. Oxygen gas will also generate a pressure. And what happens if you combine the 2 gases into the same container with the same volume? Well, the total pressure is simply the sum of each of the pressures when they are alone. When you have nitrogen alone in that container, there's a pressure there for nitrogen. When you have oxygen alone in that container, there's a pressure for oxygen. If you mix the 2 gases together, the total pressure inside this container would be the sum of the partial pressure there. So these are what we call the partial pressure in the mixture there. So how do you figure out the total pressure? Total pressure equals to the sum of the partial pressure. Now if you know the partial pressure, add them together, you will be able to determine the total pressure. If you know the total pressure and partial pressure for one of the component, the difference between the total pressure and partial pressure for one of the component would be the partial pressure for the other component. So that's a very simple relationship. Total equals to the sum of each individual. That's it. Well, it has something to do with the quantity in terms of moles, with the quantity of the gases that we have in there. Okay? It's not a simple summation. Well, in the sense, the total pressure is the simple summation, but the partial pressure for each of the gas also has something to do with the amount of each of the gases there, simply because of that equation. So pressure equals to nRT over V. Volume is going to be the same. If you mix everything into the same container, and they all have the same volume. Okay, so R and T, you're mixing things under identical condition. So all of these things are identical for the mixture. Pressure is directly proportional to the number of moles. So the relative quantity in moles of each of the components will determine how much is the partial pressure. So from PV equals nRT, you can see pressure is directly related to the number of moles. Okay, so in Dalton's law basically says the sum of partial pressure of all gases in a mixture equals to the total pressure. So in the mathematical equation there, and this is what we have here, if you have a mixture of gas A and B and C, total pressure equals to PA plus PB plus PC. Using the ideal gas law equation for each of the gases there, PA would equal to NA times RT over V. Okay? So PB equals to MB times RT over V. And PC equals to NC times RT over V. And if you add them together, this is what you get. If you add PA plus PB plus PC, RT over V is the term in common. So we can take them out of the parentheses here. So NA plus MB plus NC. That's the number of moles of A, B, and C. While you add all the moles together, we call it N total. So here we introduce the concept of mole fraction. So in this case, we have P total equals to N total times RT over V. Okay. Now, if you take the ratio between each individual gas, the partial pressure for each individual gas, to the total pressure there, and then PA over P total would be NA over N total. Just RT over V cancels out. Now, this NA, number of moles of gas A, over N total is what we call mole fraction. It's the molar ratio between the number of moles of one component to the total number of moles of everything combined in there. Okay, so X is what we call the mole fraction. The number of moles of a component in a mixture divided by the total number of moles of everything in the mixture is the mole fraction. Now the relationship between the total pressure and partial pressure for a particular mixture there is that PA, the partial pressure for gas A, equals to the mole fraction of A times the total pressure. So if you know the total pressure, air pressure is 1 atm. That's the total pressure. Mole fraction of oxygen or mole fraction of nitrogen in the mixture of air times the total pressure will give you the partial pressure for nitrogen and or oxygen. Okay, so in this case, this is the equation that we need you to remember there. And the relationship between the partial pressure of a particular component to the total pressure of the mixture there is the mole fraction times the total. Now, mole fraction, the mole fraction is related to volume. PV equals to nRT. So N and V, Avogadro's law, the more volume, the higher number of moles, the bigger the volume. So volume is related to number of moles. Therefore, mole fraction is also related to volume by percentage. So the partial pressure for a particular gas in a mixture equals to the percentage by volume of that gas times the total. So we know 21% of air is oxygen. So if we have 1 atm as the total pressure for the air, the mixture, what's the partial pressure for oxygen gas? Well, 21% of air is oxygen, so 0.21 times 1 atm, 0.21 atm. That's the partial pressure for hydrogen, for oxygen. What's the partial pressure for nitrogen? Well, 78% of air is nitrogen, 0.78 times 1 atm. So the partial pressure for nitrogen in the mixture of air is 0.78. Well, 0.78, 0.21 adds up to 0.99, close to 1 atm. So that's a simple relationship. Partial pressure to total pressure. It has something to do with either the mole fraction or the percent by volume. Okay? So that's what Dalton's law of partial pressure is all about. Total pressure equals to the sum of individual partial pressures there. And the relationship between the partial pressure and total pressure is given in these two equations there. Now these two are basically molar of the volume by percentage versus the mole fraction. They are essentially the same thing because the number of moles is proportional to the volume. Okay? So the percentage by volume is essentially the same thing as the mole fraction. Mole fraction, this is how we determine the mole fraction. Moles of each component divided by the total number of moles. Okay, so in this case, we can ask you to do a calculation here. Now, we're talking about scuba diving there. Now, when you go scuba diving there, you carry a pressurized gas tank. And you may think we just put air in there so that you can breathe. No, you can't. If you put just the regular mixture of air, 78% of nitrogen, 21% of oxygen in there, you pressurize it and increase the total pressure to 9.5 atm, you would have too much oxygen in your body. Too much oxygen is actually toxic. So the mixture of the gases in your pressurized tank when you go scuba diving is actually 98% of helium, 2% of oxygen. Only 2% of oxygen.